Hello, I'm Rajnish Kumar. I'm going to present my submission for week 4 credit assignment 3, PySpark click count analysis on Google Cloud Data Pro. The objective of this assignment is to calculate the number of clicks between different hours of the day. There are 4 bins here: 0 to 6, 6 to 12, 12 to 18, and 18 to 24. And we have to implement it using PySpark on Google Data Pro with two separate implementations, one using RDDs and another using data frames. So my approach here is to create a Google Cloud bucket. I've created it with the name IBD ITMBS GA4, and then create a data pro cluster, which I have created here with GA4 cluster name. And I have implemented two separate PySpark programs. First using RDD and another using data frame. And here it takes the date from each timestamp in the input file. It categorizes it into one of the 4 bin, and then it count the occurrences. And yeah, that's all. So we'll see that in a while. So first, I have created this README file which contains all the commands which I used to do this project, do this assignment. So first, I set this ITM-BS project, which you can see I have ITM, IBD ITM-BS project. And then I created the cloud bucket, which you can see I have here. And then I uploaded the input CSV file to the cloud bucket. So I can do it again. It will replace the existing one. And then I uploaded the PySpark scripts, the main RDD file and the main data frame file. Then I created DataPro cluster, which you can see here. So since this all takes a while and we have to record the video within a 5 minutes, I have done this all earlier. So I'll just submit this job since I already have the cluster. You can see this is the input file which I have here. In this, I have script file where I have both the scripts, main and RDD. I have output RDD file where I have these two files. I'll download and I'll show you this file. So this is the output of the RDD implementation. Let's try the other command here. This is the data frame part. So now we saw that the RDD had successfully created the output file, and this is as expected. You can see the input file here, and there are for each time bin there are 5. Let's wait for this program to complete. Once this completes, you will see the output in the output data frame folder. Yes. So this is the one output data frame, and here is the output for RRD file. So for both RRD and data frame, you can see the output is exactly same. Now let's go and see our programs. So I have this data frame.py where I have a function get time bin UDF, and inside that I have another function get time bin, and from the input file we get the different timestamps. From there we are finding out the date and time, and according to the that we are categorizing it into 4 different bins. And then in this process with data frames I have uh, so it creates a object bin count, and then from the input file it counts the number of frames for each bin, and then finally we are writing it into the into a file, and we are saving it on the output file, which is the path for our output folder. And similar to the data frame we have for RDD also, same way here also we are first assigning the time bins, and then we are processing, we are initializing initially with the 0, and with the for loop we are assigning the actual counts. We are iterating through and updating each of the beans, and then finally we are writing to the Google Cloud. We are writing to a file, and we are saving that file into the Google Cloud bucket. During the implementation, I encountered few challenges. Uh, Initially, I had issue parsing the different times stamp format, which I solved by implementing multiple format parser in the get time bin function. I didn't encounter any significant error during the execution. However, I did test the code with different timestamp format to ensure it works with different timestamps.